In 1806, the Prussian military encountered a processing load it could not handle. At the battles of Jena and Auerstedt, their forces were routed by Napoleon's imperial army, leaving the state and military apparatus broken in a matter of weeks. At the time, military control was limited by physics. A commander could only direct the troops he could see. Napoleon Bonaparte broke this physical limitation through sheer processing speed, functioning as a statistical anomaly in 19th century warfare. If we map this command structure, Napoleon functioned as a single central processing node for his army. Every variable, troop movements, terrain shifts, enemy positions, was transmitted directly into this central mind. He computed these variables and returned directives with minimal latency. This processing speed overwhelmed the sluggish hierarchical blocks of the Prussian army. Prussian commanders waited hours for top-down orders. By the time those instructions arrived, the battlefield realities had shifted, rendering the orders useless. The immediate result was the routing of the Prussian state and its military. Within weeks, an institution that had dominated Europe for 50 years was reduced to impotence. This culminated in the Peace of Tilsit in 1807, stripping Prussia of half its territory and placing its standing army under severe restrictions. Relying on an individual's processing speed creates a fragile architecture. It is an unscalable model that invites systemic collapse. There is a thermodynamic limit to centralized command. Even the most capable human brain can only process a finite number of variables at once. If that central node is severed by distance, illness, or death, the entire army is paralyzed. Analyzing the failure of 1806, military reformers Gerhard von Scharnhorst and August von Gneisenau recognized this structural flaw. Their analysis suggested that a modern state could no longer stake its survival on the statistical rarity of birthing a strategic genius. To survive, Prussia had to engineer an institutional architecture that made human genius unnecessary for success. In 1810, they installed new institutional hardware, the Kriegsakademie, or War Academy. They discarded aristocratic patronage, replacing it with selection criteria driven by mathematics, geography, and proven intellectual merit. Karl von Clausewitz, one of the Academy's first directors, designed the core curriculum. Clausewitz did not teach a rigid set of rules. His goal was to install a universal analytical operating system across the entire officer corps. The examination process functioned as a mechanical filter. The majority of applicants were discarded, leaving only the most capable processors. The Academy operated as an industrial factory, designed to strip away individual idiosyncrasy and mass-produce standardized analytical minds. The ultimate output of this factory was the General Staff Officer. These officers were trained to analyze logistical variables and physical terrain using identical logic. This shared logic was calibrated through the Kriegsspiel, a tabletop wargame testing environment. When presented with the same battlefield variables, any two staff officers were engineered to arrive at the same operational conclusion. This produced an interchangeable cognitive node. When an officer is killed, a node in the network drops offline. Thanks to standardized training, another officer seamlessly takes over their exact work. The replacement occurs with zero disruption to strategic intent. This institutional redundancy stood in sharp contrast to the personality-driven armies of other European powers. The system removed the historical reliance on charismatic battlefield commanders. Prussia had engineered a redundant cognitive network where the individual soldier was expendable, but the command structure remained functional. By the mid-19th century, Helmuth von Moltke the Elder took command as chief of the General Staff. Industrialization was scaling armies massively, moving from tens of thousands to hundreds of thousands of men. The railway network allowed Prussia to concentrate 285,000 troops with high precision. The General Staff functioned as a logistical planning hub, mapping out timetables and troop deployments years in advance. The era's primary tool for long-distance data transmission was the telegraph. A front now spanned hundreds of miles. It was physically impossible for a single commander to maintain line-of-sight control. The network was now too massive for a single central headquarters to process all incoming battlefield data, regardless of telegraph speed. Achieving industrial scale was useless without a software update to prevent the massive network from collapsing under its own weight. Other nations relied on operational software called Befehlstaktik, or command-type tactics. In this model, detailed orders are pushed exclusively from the top down. This generates inherent latency between observation on the ground and action from the top. Clausewitz termed the unpredictable reality of war friction, the sudden weather shifts, the lost communications, and unexpected enemy contact. Local friction causes a high-latency system to freeze. Frontline units wait for updated orders that arrive too late to be effective. A rigid command structure that requires permission to act cannot survive the chaotic reality of the battlefield. Prussia implemented its ultimate algorithmic update, Auftragstactic, or mission-type tactics. The first parameter of the algorithm is simple. Central command issues only the ultimate objective. They dictate the what and the why. The second parameter grants subordinate local nodes total operational freedom to determine the how. Junior nodes are explicitly required to resolve friction independently. This localized decision-making happens without querying the central headquarters for permission, reducing operational latency. The algorithm's ultimate failsafe required nodes to actively disobey prior constraints if local conditions changed, provided it served the higher intent. This created a fault-tolerant system that adapted to its environment faster than the enemy could react. French and Austrian armies were bogged down by centralized bottlenecks, while Prussian units maintained operational fluidity. This system only worked because the Kriegsakademie had already ensured every node processed information identically. Prussia's ultimate victory stemmed from this engineered decentralized hive mind, which conquered the friction of war through distributed processing.